Let's complete this chart by analyzing the functions that we've seen so far in this lesson. Okay, our first column is done for us. We know that our function is y equals 4x. Our initial value is going to be 0, and our rate of change is going to be 4. We're going to use the equation y equals mx. Okay, the rate of change is always whatever is in front of this x. And our initial value is always going to be the first answer that we put in, our first input. Okay, so just by looking at this problem, I know that there's no exponents, so this is going to be a linear function. Let's take a look at the next problem. My initial value, again, is going to be 0. I know my rate of change is going to vary because, once again, this is an exponent, a problem with an exponent. Okay, I'm going to change this form into this form. Okay, that makes my y equal mx plus mx squared. Okay, my x is squared, and all I'm doing is I'm changing my y equals mx plus b into the equations to fit whatever this narrative is here. Okay, and when I know that my y equals mx squared, look at that exponent. That means that my equation is going to be nonlinear. Look at the next problem. Notice now I have a plus 2 here. Okay, that's my b. So my initial value is going to be 2. So that my rate of change is going to vary because of that exponent right there. My equation form is y equals mx squared plus b. And my linear, whether it's linear or nonlinear, we're definitely going to say it's nonlinear because of that exponent. Try the next one. Y equals 2x plus 1. What is my initial value going to be? What's my rate of change going to be? Is it going to be linear or nonlinear? Just by looking at this equation form. So that my exponent, there's no exponent, so I know my initial value is going to be 1. I know that my rate of change is that constant in front of the x. That's going to be 2. And then I know that it's going to be a linear function because there's no exponent in here. It's just y equals mx plus b, our slope-intercept form equation. My initial value for my last function, my initial value is going to be 0. My rate of change varies. Okay, my initial value is 0 because there's nothing here. Okay, my rate of change varies because I know this is an exponent. My equation form is y equals mx cubed. And we know that it's a nonlinear function because there's an exponent here. The problem says, let's take a look at that chart now. Let's analyze that chart. In the equation y equals mx plus b, right here, does m represent the initial value or rate of change? And here, we see that our initial value, that 1, comes from here. It comes from that rate of change. What does b represent? We know that b, okay, that 1, b, is our initial value. It's our first value where we first plot. And then why is it that way? Well, it's that way because to find the y value for any x value, you multiply the rate of change by the x value. If the initial value is not 0, then you have to add the initial value after multiplying to find an ordered pair. Number 6 asks, according to your observation so far, so by looking at this table, what equation form or forms define a linear function? Okay, so we're looking here at this equation form on our table, and look at everything we have here. Which equations are linear? y equals mx and y equals mx plus b are both of the changes in y compared to the amount of x in how x changes is always going to be the same. It's always going to be constant. Let's take a look at number 7. It says work in a group, so we're just going to do it on our own, and predict whether each is a linear function. Graph each equation on a separate sheet of paper and describe the results. Okay, so just by looking at our equations and from what we've learned so far, we know that this equation here is going to be a linear function because the graphs should prove it because there's no exponent here. Okay, but because there's an exponent here, the graphs might indicate that this is a non-linear function, and the graphs will be able to prove that. Once you are done with page 75, we will do page 76 and 77 in class. This week you will have a quiz on lesson 7. That was our previous lesson that we learned last week. And then in your practice pages, you should be doing 73 and 74 in your practice book, not your student textbook, your practice book. It should be like green, and it should have a green cover, and the pages with the numbers should be black and white, and it should be green. The highlights should be green. So pages 73, 74, and you should do number 1, 2, and 4. That should be completed this week for homework on Wednesday.